Welcome to this comprehensive guide on component-based scripting in Unity, designed specifically for beginners. Unity's component-based approach is a powerful paradigm for game development, emphasizing modularity and reusability in your projects. It involves creating small, independent scripts, known as components, each managing a specific aspect of a game object's behavior or functionality. These components can then be attached to game objects, allowing you to build complex behaviors by combining different functionalities. This system offers a flexible alternative to traditional object-oriented programming, which often relies heavily on inheritance for code sharing. In Unity, every object in a scene is fundamentally a game object, serving as a container for various components. These components define a game object's behavior and properties, including its transform for position, rotation, and scale. Other essential components include a renderer for visual appearance, a collider for physical interactions, and your own custom scripts. Scripts written in C# are the primary method for creating custom components in Unity, extending the engine's capabilities. By inheriting from the MonoBehavior class, a script can be attached to any game object and seamlessly interact with Unity's engine. Modularity is a core benefit, as component-based scripting breaks down complex systems into smaller, more manageable parts. Each component should ideally have a clear, single responsibility, making your code easier to understand, debug, and maintain over time. Reusability is another significant advantage. Components can be reused across multiple game objects, saving considerable development time and effort. For instance, a basic movement script can be attached to various characters or objects throughout your game world. Composition over inheritance is favored in this design, meaning game objects are built by combining components rather than inheriting behavior. This approach offers greater flexibility and helps avoid the common pitfalls associated with deep inheritance hierarchies in traditional programming. Let's walk through the process of creating and using components in Unity, starting with script creation. First, create a new C# script within your Unity project. This script will automatically inherit from MonoBehavior. Next, open the script in Visual Studio to write the code for your component, defining its desired behavior or functionality. This might involve handling user input, manipulating object properties, or interacting with other components in your scene. To attach the script, simply drag it from the project window onto your desired game object in the hierarchy or scene view. Alternatively, select the game object and use the Add Component button in the inspector window to search for and add your script. Once attached, you can configure the component's properties directly in the inspector window, adjusting its behavior without modifying the code. Adhering to best practices ensures your Unity projects are robust, maintainable, and scalable. The single responsibility principle dictates that each component should have one clear, well-defined purpose. Avoid creating God components that attempt to manage too many disparate functionalities, as this complicates debugging and maintenance. Components should communicate through well-defined interfaces, promoting decoupling and making them easier to change or replace. It's best to avoid frequent use of GameObject, find, especially within the update loop, due to its inefficiency. Instead, cache references to components in private properties during start or awake for better performance. Always use namespaces to prevent naming conflicts between your own libraries and any third-party code you might integrate. Adhering to a consistent code style guide ensures your team develops clean, readable, and scalable code. Understanding C# scripting basics is fundamental for effective component development in Unity. Variables are used to store data within your scripts. Making them public exposes them in the inspector for easy adjustment. For private variables you wish to expose, use the serialize field attribute, offering more control over encapsulation. Functions define blocks of code that perform specific tasks, such as start, which is called once before the first frame update. The update function is called once per frame, making it ideal for continuous logic like movement or input handling. Fixed update is called at a fixed rate, primarily used for physics-related updates to ensure consistent simulation. OnCollisionEnter is a crucial function called when a collision occurs, enabling interaction between physical objects. You can access other components on the same game object using getComponentT, where T is the component type, for components on child or parent game objects. Use getComponent in Children T or getComponent in Parent T respectively. To create new game objects at runtime, use the instantiate method, commonly used for spawning enemies or projectiles. Unity offers both visual scripting and C-sharp scripting options, each with distinct advantages. Visual scripting uses a node-based interface to create game logic, often easier for those new to traditional coding. It's excellent for fast prototyping and iterating on game mechanics, allowing quick visual feedback. C-sharp scripting, conversely, involves writing code using the C-sharp programming language, offering greater power and flexibility. It provides more granular control over game functionality and is generally more efficient and optimized for performance. The choice between visual and C-sharp scripting depends on your project's needs and your personal skills. Visual scripting can be a good starting point for smaller projects or for individuals new to programming concepts. C-sharp scripting is generally preferred for larger, more complex projects requiring higher performance and extensive customization. It's also possible and often beneficial to mix and match both types of scripting, leveraging their respective strengths. For beginners in Unity, mastering component-based scripting with C-sharp is an essential skill. By understanding these core concepts and following best practices, you can create robust, maintainable, and scalable games. Thank you for joining us in this guide to component-based scripting in Unity. Keep exploring and building.